One of the biggest goals in most people's lives is to buy a house. When you go to a bank and apply for a mortgage, they run through a lot of different numbers and conclude with one single payment. However, most people don't know how this payment works, and even if you were to ask them, they would say that they just plug it into a calculator and get this answer. Most people think that it is a very difficult thing to get, but in fact, you only really require a high school algebra education to learn how to get it. In the previous video, we showed how mortgage works and showed two calculators that ended with the same amount. But how did these calculators arrive to the same number? In this video, we will come to understand the equation behind it all and how to create it out of scratch. Instead of thinking about mortgage the traditional way of accruing interest, I like to take the approach that mortgage, its interest, and your payments happen independently from one another. Let's use an example to understand what I mean. Let's say you get a loan of $1,000 and every month you're charged 20% of the value you have or owe. On month 1, we take the money we owe, which is $1,000, and increase it by 20%, giving us $200 in interest for the first month and making the new money we owe as $1,200. On month 2, we do the same thing. However, this time we're not only taking 20% of the original loan, but the interest of that loan. This means we owe $240 more, but this is where our thinking should start diverting from the original way. This month, we do not owe $240 altogether. Rather, we owe the same $200 from the original loan, which we will color yellow, and an extra $40 from month 1's interest. Therefore, we will add $40 to the blue bar, and not the yellow one. So interest on the loan will be a new color, and interest on previous interest will remain the same color. On month 3, we do the same thing, the loan starts the same, a new $200 interest bar shows up, and we add 20% to the pre-existing bars. Here's the math if you want to take a moment and try to understand how it's working. Same pattern happens in month 4. However, I would like to highlight that this happens in the background of your loans, and you only see the end number when we sum the loan and its interest. By this time, your interest has surpassed the original loan value. Now let's say that you pay a one-time payment of $400 on month 1. Therefore, month 1 goes from $1,200 to $800 that you owe. Now, a one-time payment shouldn't matter when you pay, but at month 4, we see that the value of your loan is almost $700 cheaper than previous. But how is that possible if you only paid $400? If we calculate how much this effect changes throughout the months, we notice that it increases. It goes from $400 to $480, which is 20% more, to $576, which is 20% more, to $691.20, which is 20% more. This proves that not only does the money you owe grow, but the money that you pay also grows. These are not payments per se, but more of an investment for the long run. Let me explain. What if you made a second payment of $400 on month 2? The $960 you owe becomes $560. Therefore, the loan starts growing again, and on month 4 we see something very interesting. We decrease the money we would owe from $2,000 to now $800. We somehow got $800 to have about $1,200 of effect. We learned that the first payment grew 20% each month, and applying that logic to the second payment, we can see that this is also the case. However, the effect of the second payment is not as large as the first one. We see that it grows in the same pattern, only 1 month behind, but that made $120 of difference. So in your loans, there should be a concept that you remember. Earlier payments have a stronger effect on the loans. Quick note that this 20% does not come from thin air, but is the same 20% as your interest. Think of it this way. When you make a payment, the bank also makes your money grow and tells you the amount that you have as a net every month. Why did I show this example? Well, I wanted you to understand the idea of the loan and your payments growing independently, as well as pointing out a good rule of thumb when paying off your loans. But our mission is to find out the magic number that will pay your loans. So let's get back to that. This time, let's approach the same example, but only using math terms this time. Month 1, we have the loan and our interest on the money we owe, which is just a loan. We notice that this can be reduced a bit by factoring out the loan amount, and leaves us with L times 1 plus I. Month 2, we have the money we owe and the new interest. Therefore, we can write month 2 to be month 1 plus 20% of the month 1. Then we can do the same as month 1 by factoring out the monthly terms, and we are left with month 1 times 1 plus I. But remember that month 1 is just saying the loan times 1 plus I. So putting that in the expression, we now get the loan times 1 plus I squared. This means that in month 2, the loan has grown twice by the interest. Therefore, month 3 requires no math and can just be written as the loan grown by the interest 3 times. Now let's do the same that we did last time and start to include the first payment in month 1. Now the equation will look like this: the loan grown once minus the payment. And since we know that your payments grow at the same rate as your loan, on month 2 we would have the loan grown twice minus the payment grown once. We can show this process mathematically, but because we know how the concept works now, we don't have to suffer through that anymore. This makes things easier on your second payment in month 2. Because this is the second time the loan grows and the first month where your first payment grows, we write the expression this way: the loan grown 2 times minus the payment grown once minus your second payment. And the payments and loans grow at the same pace, but each growing once more than the next. Month 3 is the same, but with our method, we can easily write this equation. Originally, we would have to write this other equation and distribute only to get where we are, simply with this new way of thinking. Also, remember that 1 plus I to the x really just means that the quantity is increasing x times, where x is the number of months that the money has had to grow. Now, if we want to solve how much you would have to pay to reduce this loan to 0, we simply make this equal to 0 and solve for p. One thing that we notice is that all payment terms are negative and that they can be added up. So let's do that first. Let's move all the p terms to the right side and then add them up. Now we can divide it by 3.64 to get that p is equal to $474.72, which took us maybe 1 minute to solve. But the answer seems a bit high, right? Let's see. Month 1, our loan increases to $1,200 and we make our first payment, which leaves us with about $725. Month 2, this money increases by 20% to $870, and our second payment leaves us with a loan of about $395. Our last month, this increases by 20% again, and our last payment reduces this to 2 cents. So what happened? Well, because our economy does not work in whole numbers, we had to round up 2 cents. So banks usually round your payment up to the next cent to account for this. Now, this equation is great, but imagine writing an equation for 12 monthly payments for 15 years, let alone 30. There has to be a better way to do this, right? Well, let's figure this out. Let's solve how much we would pay on a loan with L with interest I for T timely payments. Well, it would look something like this. This means the loan grows T months. Your first payment would grow T minus 1 times. Your second payment would grow T minus 2 times, and this goes on until the final payment is made. Now, we add a 0, since these payments should make you debt-free at the end. Remember, we can move the payments to the other side of the equation. We can also factor out the terms with P, like we did in the previous example. This equation looks a bit nicer, but we aren't quite there. We notice that the terms all have a similar pattern, where their power changes and grows by 1 each time. Therefore, we can write it in a summation. The equation is L times 1 plus I to the T is equal to the payment times the sum from x equals 0 to t minus 1 of 1 plus I to the x. This is a better, more concise equation, but we can do better. There is a simple, almost illegal move that we can do to find the closed form of this summation. A closed form means we don't have to write the equations with periods and a bunch of plus signs. The trick here is to find 2 ways of writing the sum of the next term, or the sum from x from 0 to t. and then use that to bridge the two ways and solve for the original sum. Let me just show you. We can write the sum from 0 to t in two ways. One way is to simply add the t term to the expression. The other way is to multiply all the terms by 1 plus I, and then adding the first term, which is 1 plus I to the 0th power, at the end. Now we use these two equations and link them together. We get method 1 on the left and method 2 on the right. Now we move the sums to one side and the non-sum terms to the other. Then we can factor out the sum from the terms and divide the equation by this term to get the final result. Therefore, the sum is equal to 1 plus I to the t divided by I. And we put this back into the equation. Now the equation is L times 1 plus I to the t is equal to P times the fraction 1 plus I to the t minus 1 divided by I. And multiplying the inverse of this fraction on both sides gives us our final equation. In the end, we get this equation. Our monthly payments are loan times 1 plus I to the t times I divided by 1 plus I to the t minus 1. But is this the right equation? Let's check. Back in our first video, we had the example that we take a $500,000 loan with an interest of 4% over 30 years. Therefore, our L would be 500,000, our I would be 0.00333 since the interest will be charged monthly, and our T is 360 months. By solving this equation, we get $2,387.07, which is what our calculators previously gave us. So this is the equation that powers all simple loans, and most people don't know how it works. But hopefully, you now understand how it was formed, at least a bit more now. Thank you for supporting the channel by liking and subscribing. If you have more questions, let us know in the comment section below.